Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Huge Numbers of Planet X System Objects in Coronagraph Images. Now in article 330 entitled Coronagraph Images Show Planet X Interacting with the Sun, I showed that the MLSO, which stands for Mauna Loa Solar Observatory, coronagraph images indicate that stellar cores appear in these images as the objects move around in a way which indicates that they are bound to the Sun. In these images, the objects look like concentric, alternating light and dark rings due to diffraction effects arising from the size of the aperture on the coronagraph eyepiece. However, the size of the ring structure also indicates that the telescope has been purposely defocused in order to hide the fact that there are objects in the Sun's corona. And here we see the object very close to the Sun. As you can see, it looks like a ring pattern with a central bright maximum. This is a diffraction pattern of an object that is emitting light in the Sun's inner corona in this case. So this image is a K-core image from July 6, 2018. So we have a bright object. This object is what I have called a stellar core. And this object appears on the Sun's western side, and the concentric ring pattern is due to diffraction effects arising from the aperture of the eyepiece on the telescope. This object remained in this position or very close to this position for some 7 hours. And for more details, you may look at article 330 entitled Coronagraph Images Show Planet X Interacting with the Sun. Because of the diffraction effects, it is difficult to estimate the object's size, but it is likely that its radius corresponds to the radius of the central bright circle in this diffraction pattern, which would make this object about 1/10 of the Sun's size, or about as large as Jupiter. Now, these illustrate what occurs to bright objects when viewed through a telescope. They are always diffraction effects. There's nothing you can do about it. It has to do with the size of the lens used as the eyepiece. And this is because light is a wave and it becomes bent when moving through a small sized aperture. So this is what a bright object would look like if the telescope is focused. It looks like a bright center, then a dark ring around that, and then another light ring, but not as bright as the central bright circle. And this is what it looks like when the telescope is defocused. So from the ring patterns we are seeing here, it's obvious that they actually defocus the telescope in order to not make these objects obvious. And these are other effects which may occur if the alignment is not correct for the mirrors and other components inside the telescope, and you may get these effects. Now, when the telescope is perfectly aligned, that's described as the telescope being in collimation. Now, there are other effects such as atmospheric turbulence, which then causes the ring structure to become distorted. And this is for the focused telescope. This is for the defocused telescope. As you can see more rings, and the rings that are defocused. And this is what occurs when we have problems with the collimation of the beam. So things are not quite aligned when we have atmospheric turbulence, and furthermore a defocused telescope. So several effects cause a bright light source that should look like that into this. It looks like a central dark circle surrounded by a distorted ring pattern, bright ring pattern. You can see the brightness in the rings. They are dark rings as well, but the whole thing is distorted. Some of them look like there is a central bright spot inside the circle, but it's faint. And so now that we know what point sources of light look like through a telescope that has been defocused and may have other problems, we can now look at a stereo A-Core2 image where lots of these bright sources exhibiting this characteristic can be seen. As you can see, there are lots of dark circles surrounded by distorted bright ring pattern here. There's one, there's another one. The more you look, the more we'll find. One, there, more. Some more there, some more there. They are everywhere. They are just everywhere. Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. They're just everywhere. There's a whole line of them. They're overlapping each other all over the place. All over. So these objects are obviously there in the they become more obvious here because the corona is not as bright, and you start to see more of the ring structure around the dark circle there. But you can see a whole lot of them here as well. There's just a whole line of them here like that. There, they are everywhere. Now, the Core2 chronograph is not on the surface of the Earth, so it's not possible for it to be affected by atmospheric turbulence. But it is obvious that something has been done to the telescope in order to simulate the effect you would obtain had there been atmospheric turbulence. It is also clear that the telescope is defocused as much as possible, so that the huge numbers of light sources are not apparent. In addition, the image is what is obtained before it is processed. After processing, the image appears to be much smoother, at which time all the light sources are not visible at all, or perhaps one or two sometimes become visible. But most of them will be gone once this image is processed. This will all appear like smooth red background mostly. Now, these light sources are not background stars because, as I showed in regard to the MLSO K-core images, background stars cannot be observed through the sun's corona, as they are simply not bright enough. So what are these point sources? These are small, or most likely small stellar cores of what is left of the planets and moons which once orbited the larger stellar cores, which are now dead stars, and which I have shown are actually brown and black dwarfs. And you may look at article 317 entitled Planet X System, Brown and Black Dwarfs with High Magnetic Field for more details. Some of the bright spots may also be larger pieces of stellar core debris produced by the stellar cores shedding their outer layers of material. And you may look at article 272 entitled Noctilucent Clouds and Planet X Debris in the Earth's Atmosphere. But one thing is for sure, there are thousands of point sources of light in the sun's outer corona. The images below come from the LASCO C1 chronograph, which is no longer in operation. The image is from 1986. I first thought it was from 1996, but it's actually, that's an 8, so this is from 1986. Notice that there were thousands of objects in the sun's corona then already. This is not surprising because the system had started coming in by 1850. when noctilucent clouds started being observed in the Earth's upper atmosphere. And you may look at article 146 entitled Planet X System, Time of Arrival for more details. So let us look at these images. As you can see, there's a jet of either plasma or an alignment of particles aligning themselves in a straight line. Both are possibilities there. Now there are thousands of dark centers surrounded by disc-shaped rings, indicating the presence of points, sources of light as viewed through a telescope, which produces diffraction effects. As you can see, 1, 2, 3, 4. Obviously, this telescope was not as defocused as the Stereo Core 2 one. You can see a lot more of these objects. The corona is just full of them, full of them. So this is a close-up of the left bottom corner, so you can more carefully look at it. You can see there are lots of little holes surrounded by bright rings. These are all most likely stellar cores or large pieces of stellar core debris. Lots. You can see these. Some of them just look like white specks. These may be the bright center surrounded by a dark circle and then a kind of ring structure around it. But they are everywhere. They are just everywhere. Lots and lots and lots. These may be bright stellar core debris. Well, some will be debris, some will be stellar cores. The stellar cores will keep coming back to the sun. The debris will spread throughout the solar system. And here's another one. This is a close-up of the top right part of the image. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. If I counted this one, 27, 28, 29, 30, 31, 32. I'll never be able to count them all. There are so many. 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 47, 48, 49, 50, 51, 52, 53, 54, 55. I don't know if I've counted them already. There are just so many. They are everywhere. Look at that. A bright center, a dark ring, a distorted bright cloud around it. There's another one, another one, another one, another one, another one. There. They are everywhere. There must be thousands of them. These light sources can be two types of objects. Although their size may vary from the size of a small moon to the size of a planet, like Earth, some may be small stellar cores, which were once planets or moons. These objects have cores which are positively charged and thus operate like super ions, and will keep on being attracted to the sun's outer layer of electrons. So although they will be ejected whenever the sun is provoked into having a CME, they will keep coming back to the sun. These small stellar cores, like the larger ones which were once stars, will share their outer layers of material and thus generate low energy stellar core debris, which will also absorb energy but will not have a core. The debris is extremely low in energy and will thus float in space, as it will not be affected by any gravitational field and will not generate any itself. But because the stellar core debris does not have a core, the debris pieces will not operate like super ions and will not come back to the sun after being pushed away from the sun by a CME, and will thus fill the solar system. This Planet X system debris will enter into the planet's atmospheres and affect them. And they will drop the energy and cause the planets to expand. Stellar core debris, dust entering the Earth's atmosphere, is what led to the appearance of noctilucent clouds in the Earth's atmosphere in 1850. And this is what is illustrated here. A stellar core has a positive core. It has lost its outer layer of electrons. And it means that it's electrostatically attracted to the sun's outer layer of electrons. This is why it keeps coming back to the sun. The gravitational attraction is extremely small because the object is extremely low in photon energy or gravitational energy. And photon energy is the energy inside its particles. That energy has been used up throughout the object's life to produce light. And once the object is now dead, it can no longer generate energy in its core, then its ability to influence other objects gravitationally, interact through the gravitational interaction, is very small. And this is because the gravitational constant, which determines the strength of the gravitational interaction, is not actually a constant. It is dependent on the photon energy inside the particles making up an object. And for more details, you may look at Article 193, stellar cores in the sun's corona. Why do they not collide with the sun? And Article 210, entitled Stellar Core Gravity, Tidal, and G is not constant. Both stellar core debris and stellar cores will pull energy from the core of a planet and cause all its layers to warm up, including its ionosphere and magnetosphere. This is what's illustrated here. You can see the energy comes out of the core of the planet and it goes through all the layers, thus warming up all the layers, including the oceans, the atmosphere, the ionosphere, and the magnetosphere. This is why everything is heating up on Earth. And for more details, you may look at Article 240, entitled Planet X System Effect on Radioactive Decay Rate and Heating of Planets. And this also causes the Earth to expand because it's losing energy to the stellar cores. And when it loses energy, it loses gravitational influence. So it is no longer able to attract matter towards its center as well as before. This causes the planet to expand, leading to fissuring of the surface as well as ever-increasing volcanic activity. And you may look at Article 258, entitled Planet X and Increased Volcanic Activity. The debris will eventually absorb some gravitational or photon energy and start being affected by gravitational fields, and will thus be capable of being attracted and impacting Earth like meteors or asteroids do. For more details, you may look at Article 304, entitled Can Planet X Cause Asteroid-Type Impacts? So in conclusion, there are thousands of point light sources in the sun's corona now, and there were already thousands there in 1986. These are either small stellar cores, dead planets and moons, or large pieces of stellar core debris. The small stellar cores that started entering the solar system around 1850 are likely to still be in the sun's corona, and thus the number of these objects is likely to have continued to increase until now. The light sources created by the debris material, which is created by the stellar cores, which are dead stars and planets, will spread out from the sun and fill the solar system. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.